invite our presenter, Abdel-Fattah Seyam, Head of Department of Textile and Apparel and Technology of North Carolina State University College of Textiles in the United States of America.
Good morning, everyone. I would like to acknowledge here the Walmart sponsorship. This is like very major money that allowed us to do the development. The author would like also to thank other contributors here. We know that the weaving process is a bottleneck, and we know also 50% of the woven fiber is converted to woven fabric. It's a major process. It is bottleneck because you have small amount of batch. We put it on warp beam and you weave it. And then once it's woven, you need to change that batch. And you can see here the nature of yarns. Yarns are weak. You know, they cannot take speed. We reached the speed limit. We reached the efficiency limit. So we need to find revolutionary ways to tackle long-term stops rather than short-term stops. We are very good at short-term stops now. We always need to work at it and improve our yarns. However, we reached the limit in everything that we could do. And you can see here, researchers are really focused on speed and efficiency, and I mentioned that, you know, people are doing a great job there. Some people need to learn, of course, all the time. However, the major players, the major weavers, know how to handle the yarns. They know their yarn limit, so they can handle the efficiency as to their best of ability. But the long-term stop, like tying in or style change, remain unchallenging. We have been doing this same way all the time. Our work will address the longer-term stop tying in process. As the title suggests, we will run the weaving while we are doing the tying in. We perform tying in here at the loom. We are talking about when you stop the loom to do tying in, to change from empty beam to full beam. You tie the old beam warp to the new beam warp. Here is the weaving downtime stops, short-term stops, long-term stops. This is summarize what has been done in the field. In terms of short-term stops, the warp stops reduced but not eliminated, and not automated either. Filling stops, including warp cause filling stops, reduced and automated for some looms. We still stop the loom, but for a short period of time. Other stops, which is electronic, and pattern change for electronic jacquard is history now. We don't stop the loom for that. We can change while the loom is running. In terms of long stop, pattern change is still a problem for cam and mechanical mechanical jacquard. We know that, and people getting away from this, but some looms still have those. Style change, we still do this manually. We do it at the loom. After drawing in, we do style change. It's long term. Tying in, we have 3 steps there. We have manual preparation for knotting and manual procedures after knotting. And at that time, everybody now, when you do it at the loom station, you stop the weaving for a long time. Maintenance, we know that, okay? This is eliminated now. We're going to eliminate this. Of course, our incentive is, I just mentioned it, and the incentive is, it's long time to stop. You lose efficiency, 60%, 7%. Some people lose 2%. It depends. So we propose here really innovative, revolutionary approach to eliminate the long-term stop during tying in. And we filed patent application before we started the working on this. And of course, when you want to solve a problem, you need money. We got the money, we have the incentive to do it, then bingo. Okay, we conducted time study to look at traditional, or the way we do tying in now, to look at how much time we stop and what this depends on. So, and also we would like to develop, or we develop, tying in equipment and procedures. Procedures are very important as much as equipment, and you will see that. This is traditional tying in time study we done at the College of Textiles, and these are the particular for the warp sheet that we got. Okay, about 3,000 yards. And here is the process. If you are familiar with it, you can see how we do it. This is the traditional tying in. We stop the loom now, okay? And we keep adding the time. We done this by video capturing, and we kept monitoring the time with every task. This all the task is before the knotting itself, right? "81 minutes and still didn't do nothing yet." Now we started tying in the knotting. We brought the machine here, the knotter, or the knotting machine, and we started doing this. 77 minutes. And then after tying in, we remove the tying in machine from the way, and we want to start the loom again. Then the loom is ready to run now with knots, as you see the knots at the bottom there. And we have some failed ends. We fix it, 2 minutes, and then brushing the knots, passing the knots, and here is the results. We have 77 minutes for the tying in itself, knotting itself, and before it 98, after it 21 minutes. Total of more than 3 hours. You stop the loom, premium loom, you pay for it, and it did nothing for you. We done at a company, P&A Industrial Fabrications in North Carolina, USA, very interested in our technology. They approached us to try one of our prototype at their facility. And the reason is, you can see, they have 372 minutes for tying in. Huge time, more than 6 hours. Okay, this is our stop tying in process. We have first step is to form wall beam with tail. This is new, how to form a wall beam with tail. Here is the concept. You form a tail beam at the bottom there, to the left. This is temporary beam. You put a tail that's long enough to let the loom run while you are doing tying in. So you calculate that length based on the speed and the pix per unit length. You can calculate that length. You do this as temporary, and then you come here, and you have the loom beam, and now you're going to make fold. You're going to make the warp sheet, one sheet folded, and you fold it by the spring rod that you see there. We can use this magnet rod or whatever rod that can stick the two that will make fold. So you can see how we made the fold, right? Now we are doing the loom beam, and the tail beam will be out of the way. After that, tail beam is gone. You don't need it anymore. Here is the loom beam that you're going to take it to the loom to do the tying in. That's the first step. This is what we did in our facility. We have sample loom, and our first prototype is to make run at our facility. So we built this beam here. This is normal warper, and we make sample. This is 20-inch wide warp sheet, and we are making the tail now. And the next step is to take that tail beam and put it on bearing or support, and then put the loom beam here, then make the fold. And we are making now a loom beam with tail. The beam on the very left is temporary. The beam at the bottom is the loom beam that's going to go to the beam. The main warp is here.
We're going slow.
The tail is shorter, of course.
I can start it.
Now you can see the beam with tail. You can see the tail now coming. The tail will be under the main warp. can see that. Okay, this is a non-stop tying in trial using passive accumulator. We want to have now accumulator to take the tail accumulated while you're doing tying in. Here is the simulation drawing. The tail will be exposed during weaving. Now you can start your tying in once the tail is elongated enough to fix it on the tying in machine. You bring the warp beam, the new warp beam, you put it at the bottom there, you bring the accumulator, and you bring the tying in machine while the loom is running. Then you start fixing now the new warp to the tying in table. You thread the tail into the accumulator and fix it to the table, tying in table. You do tying in, all that while the loom is running. You're accumulating the tail this way, and then you're going to feed the tail. After tying in now, you're feeding, the accumulator is feeding the tail to the loom to weave from the tail, non-stop. You may stop for a few minutes to change the beams. Now you put the beam on the loom, the new beam, all the beam is gone. And now the accumulator is a special accumulator. You have a loop that you need to get rid of the accumulator. How you do that? We have a splittable design. The accumulator is splittable side. We take the side out, so we can disengage the accumulator out of the way and take it to the next process, tying in process. Here is the accumulator is ready to disengage after it depleted the tail. And now the new warp is weaving. Now we are doing this now in our machine, in our lab. You can see the tail at the bottom started where the tape is. The machine is running and tail is emerging. We bring the loom beam, the new loom beam, and we bring the accumulator, very passive accumulator, very simple way, just to prove the concept. Then we thread the tail to the accumulator. We take the new warp beam, put it on the tying in machine that we brought in. The machine is still running. We fix the warp sheet of the new beam, and then we're going to be ready to fix the tail sheet to the tying in machine. Now we have the two sheets in the tying in machine. You start tying in. Again, the loom is running. And you can see the loom is running while we have the two sheets ready to tie in. Okay, we brought the tying in machine here, tying head, and we're going to start knotting. We finished knotting, and you can hear the loom. The loom is still running, and we're going to show you the loom running. The loom is running there. Tying in is done. This is the old beam ran out, took it out, and then the new beam we put in. And if you have clamps, you can actually put the new beam without stopping. You may stop for a few minutes, you may stop for 15 minutes. If you have 6 hours and you stop for 15 minutes rather than 6 hours, it's a great gain in efficiency. We just put the new beam without stop because we still have the warp clamp.
In place now? Is the beam in place? Yeah. Where is the empty beam?
Okay, now the knotting machine or tying in machine is gone, and we are feeding the loom from the accumulator. And then at the end here, we have to put tension, manual tension. This can be automated also. And what we did actually, we stopped the loom here to take the slackness out, and we rotate it on the warp beam itself. So we can stop for a few minutes to do that. And there's brushing the knots. passing the nuts, and weaving from the new one. In conclusion, we successfully demonstrated the non-stop tying in trial using passive accumulator prototype, and we learned that material waste reduced actually. Procedures and preparation for tying in reduced because we did the tail ready to tie in before tying in. And we build this huge accumulator, full 68-inch to go behind 68-inch loom. And the accumulator was built by Menzel, USA, and it's shipped as assembled already at P&A company, our collaborator Weaver. Okay, we are planning for trial soon. We did marketing study, but I don't have time to talk about it here. And the next step after that is to commercialize it. After we get this considered second prototype. We really succeeded. We thought that we're going to do 3, 4 prototypes, but looks like the second prototype, we may tweak it a little bit here and there, and then we'll have commercial equipment. Of course, nothing is free, right? You need to buy accumulator, of course. Each warp beam with tail requires 15 minutes to make the tail, but the capacity is there. Everybody has enough capacity in their warping machine. Equipment cost is really not that expensive. And this prototype that we built with Menzel is not expensive, and it's going to be cheaper if they make more. And each tie-in machine needs accumulator and tail beam support. Okay. Space behind the loom, some cases, P&A, like companies like P&A, they got the space. Other companies, they may have tight space, then we need to have a compact accumulator design, which is not impossible. This is actually P&A mid-A-tail beam, and these are the opportunities. We have opportunities for Weaver, opportunities for accumulator. Of course, the efficiency is great saving. If you can increase efficiency by 1-2%, it is like a great achievement in weaving. Like I said, weaving is a bottleneck in the pipeline of making fabric. So if you can gain 1%, 2%, and some companies will gain 6-7%, this is really great opportunity for weavers. And for machine maker, there's a lot of accumulator that you can build. We looked at the number of looms in the world and estimated every 50 loom will have probably one tying-in machine, which require an accumulator. Thank you very much and I'm happy to take any questions.
Are there any questions, House Speaker?
I suppose after you commercialize your equipment, you are willing to sell the accumulators to the ready weaving facilities. We have a weaving facility, and our weaving machines, in between, there's only 1.5 meter blank. Do you think it is suitable to?
Sorry, 1.5 meter, you can build the accumulator to any size you want. If you make it 2 meters, you can take 1.5 meter. If you want to have 1.5 meter exactly, you can do that. So you just request the specs.
I think you're thinking to commercialize after 2012?
We can commercialize anytime. You ready? You ready to buy?
Maybe.
Yeah, we can be ready in 1 year. Yeah,
this is good. Thank you.
Firstly, have you ever tried before the more speed machines we have, maybe 600 RPM? Have you tried this in these machines, this system?
You can the speed the speed of the machine and the picks per unit length, per centimeter or per inch, dictate the tail length. So it doesn't matter whether the machine is high speed or low speed, it doesn't matter.
We have a lot of problems end of the beam. For for example, loose yarn. While working during tying, we have some quality problems on the fabrics if we have speedily. But your machine is running very, very slowly. Maybe it's not a problem, but we have a wide and maybe 10 warps of the one beam.
I believe when you make a tail, and I know that at the end of the beam, some people actually through 25 meters, 50 meters, they are useless because they are crushed and slack. If you make a tail and you work with the tail and brush it and put tension on it, you can avoid the waste.
Then how many meters you waste warp yarn?
What's the measure of the waste?
Waste yarn, warp yarn. How many meters we spend for waste?
I don't think you need, for this process here, if you just cut it to straighten the warp. If you put the tape, you tape it. You can put also, whatever you want at the end. When you put the tape, you may cut a meter or so. But the tail, you work with the tail. The end of your warp is under control now. With the huge beam and crushed, I used to work in the industry, and out of 5,000 meters, we threw about 50 meters in the end. It was useless because they are crushed. With the tail, actually, you can take the tail, straighten it, and put tension, and you can eliminate that waste.
Okay, have you got any additional tension control system on accumulator?
The accumulator can have tension control, and you can add tension device to the accumulator or beside the accumulator.
Okay, thank you.
We are aware of the tension.
And the last question? Okay, so thank you very much,
Thank you.
Mr. Seyam.